Hello my dear students, I warmly welcome you to CR Digital Classes. So in this lecture we are going to discuss about backward difference table. Define backward difference and explain the procedure to construct a backward difference table. Okay. So first of all, y is equal to f of x be a function, and if y0, y1 up to so on y suffix n represents a set of values of y. Okay, these all are the corresponding values of small y. Then the differences y1 minus y0, y2 minus y1 up to so on y suffix n minus y suffix n minus 1 are called as first backward differences. Okay, the same differences also we discussed in the previous lecture, first forward differences. Now those are also called as first backward differences, and mathematically these differences are denoted by reverse delta. Okay, previously we discussed with the delta. Now reverse delta y1, delta y2 up to so on delta y1. Some mathematicians they were called it as a nabla. Okay, nabla y1, nabla y2 up to so on nabla y1. Simply we can also call it as a del. Okay, del y1, del y2 up to so on del y suffix n respectively. Here del y1 is equal to y1 minus y0, del y2 is equal to y2 minus y1 up to so on del suffix yn is equal to yn minus yn minus 1, where this operator reverse delta is called backward difference operator. Okay, so this delta is called forward difference operator and reverse del is called backward difference operator. So here first order backward differences are in general formula is given by nab y suffix r is equal to yr minus yr minus 1, or del y suffix r is equal to y suffix r minus y suffix r minus 1 for r is equal to 1, 2 up to so on. So now in second backward differences can be calculated as del square y suffix r is equal to del y suffix r minus del y suffix r minus 1. So that is the general formula for the second order backward difference operator. Similarly, if you proceed in this format, nth backward difference operators can be defined as del power n y suffix n is equal to del power n minus 1 y suffix r minus del power n minus 1 y suffix r minus 1, where r is equal to n comma n plus 1 comma up to so on. So this is the total first order backward difference operator and second order backward difference operator and nth order backward difference operator. So you can see the table of the backward difference operator. So in problem based on this backward difference operator, you will know x1, x0 up to so on x suffix 6. Okay, and corresponding values for x0. The original function is y is equal to f of x. That is the standard notation of the given function. Whenever you substitute x0 in f of x, then the corresponding value is y0. So therefore y0 is equal to f of x1. Okay, sorry, y0 is equal to f of x0 and y1 is equal to f of x1. In this format, all values up to y6 are they will give in the problem only. Now with the help of those y1, y2, y3 up to suffix y suffix 6, okay, we have to make a backward difference operator table. So now first of all here you can see that y1 minus y0 you can take it as, okay, difference of y1 minus y0 you can take reverse del y1, okay, or del y1. So next to y2 minus y1 you can write y2 minus y1 you can write del y2. So in this format, next this total column denotes that first backward operators. Okay, first backward difference operator. Next here you can see second backward operator del square. So this total column deals with second backward difference operator. You know very well. Here del square y2 you can write del y1 del y2 minus del y1. Okay, you can write del y2 minus del y1 while solving the problems based on this in this method. So here each and every value will exist in the numbers format. Okay, so in the general process only we are denoting with the symbolic expression, but in the problems we can write numbers in them. So therefore this column represents the third backward difference operator. Okay, so and here you can see the fourth backward difference operator, and this total column represents those values, and this one is the fifth backward difference operators, and the last one is the sixth backward difference operator. Whenever you take the x values up to x suffix 6, you will get that delta power 6 is the last value. If you take the x suffix 5 is the last value, you will get the delta power 5 is the last difference backward difference operator. Okay, so based on this table only we can see here delta y suffix 1 is equal to y1 minus y0. Okay, or else you can call it as a nabla. Nabla y suffix 1 is equal to y1 minus y0. So next, del square y2 is equal to del y2 minus del y1. Del y2 minus del y1. So therefore, substitute the corresponding values. If you simplify them, you will get these values y2 minus 2y1 plus y0. Okay, here also y2 coefficient is 1, y1 coefficient is minus 2, and y0 coefficient is 1. Okay, plus 1, minus 2, plus 1. These all are the binomial coefficients. Okay, correspondence values of small y will get the binomial coefficient values. So next, del cube y suffix 3 is equal to, you will get y suffix 3 minus 3y2 plus 3y1 minus y0. Here also you can observe that y3 coefficient is 1, y2 coefficient is minus 3, y1 coefficient is plus 3, y0. So if you write them in order, 1, minus 3, plus 3, minus 1. Okay, these all are the binomial coefficient with alternative signs. So it is clear that any higher order backward difference can be easily expressed in terms of y ordinate. With the help of the table, we can further any higher order backward difference operator can be expressed in the ordinates, y ordinates. So therefore, binomial coefficients occurring for y ordinates as a coefficients on RHS. Okay, so we can discuss that point here. So this is the total explanation of the backward difference operator. So while solving the problems based on this method, so you will know clearly. Okay, so this is the total explanation of this problem. I hope you understood this problem very well. In the next lecture, we are coming with another interesting topic. Make a perfect practice, prepare well. Until bye, thank you.